All right, so taking a look here at the second game of the October 1993 LSAT, we see a game with 7 people who are J, K, L, M, N, P, and Q. And of these 7 people, exactly 4 will be selected to attend a diplomat's retirement dinner. So 4 are being selected, so 4 are going to be in this retirement dinner, while 3 are going to be out. So again, we have an in-out group game. So turning my attention now to the conditions. The first condition tells us that either J or K must be selected, but J and K cannot both be selected. So let's take a look at that and see what we can conclude. Again, we know either or. If I don't have J, then K must be present. If I don't have K, then J must be present. But just either or leaves open the possibility that both K and J are present together. But condition 1 told us, but J and K cannot both be selected. So not only do we have either or, we also have not both, which tells us that if J is selected, then we can't have K. Contrapositive, if we have K, then we can't have J. And this allows us to make a deduction that one of J or K is in and the other is out. Moving on to the second condition. The second condition tells us either N or P must be selected, but N and P cannot both be selected. So same exact rule as our first condition, just now with N and P as opposed to J and K. So if I don't have N, I must have P. If I don't have P, I must have N. But if I have N, I can't have P. And if I have P, I can't have N. Which again allows us to conclude that one of N or P is going to be in while the other is out. Which brings me to the third condition, N cannot be selected unless L is selected. So again, we know that if we have N, then we must have L. Contrapositive, if we don't have L, we can't have N. And the last condition tells us that Q cannot be selected unless K is selected. So again, we know that if we have Q, we must have K. Contrapositive, if we don't have K, then we can't have Q. So now that we have our base and all of our rules written down, you should notice that this game is pretty restrictive. We've already placed 2 of the 3 variables in the out column. All we need is 1 more and we figure out exactly what's going on in this game. So let's see. Again, we have a number of different possibilities here, but let's see if we can narrow them down. So in the first scenario, I'm going to pick J. If J is in, I know K is out. In terms of having J in or K out, notice having K out tells me from rule number 4 that Q is out. So then I would know one of N or P is in, and the reverse would be the other variable out, leaving L and M to both be in. But again, that's not the only possibility. I just happen to decide I'm going to put J in instead of K. But what if, on the other hand, I decided to have K in? Well, notice having K in tells me nothing. K is necessary in rule 4, so it's possible Q is in, it's possible Q is out. But I know if K is in, J is out. Having J out tells me that K is in, but we already knew that, so that's not going to help me. Then I turn my attention here to N versus P. Now, if I have N in, I know for certain from condition 3 that L is in. Again, I know that now P would be out. Who is left? It would be M and Q. But again, nothing forced me to have N in this scenario, so why not try to draw out the scenario where we have K and P? Again, placing exactly where we were. Now, instead of having N in, I'm going to place P in. Unfortunately, having P in tells me nothing other than what we already know, that N is out. N being out, again, doesn't tell me anything. So who's left? We have M, Q, and L. You notice that we're going to have try options here. Any two of those three can be in, and the remaining would be out. And that would be the setup for this game.